There have been 6 named storms in the Atlantic so far this summer, but none has reached hurricane status. In only 3 of the last 30 years have we reached the end of August without at least one hurricane. One reason for the lack of hurricanes so far this year requires us to go to Africa, specifically a huge region of the Western Sahara Desert, where gusty winds often kick up sand and dust high into the sky, especially in summer. Winds above the surface at these latitudes are normally from the east, and they carry the hot, dry, and dusty air out over the Atlantic Ocean, where it runs up and over the relatively cool and dense Atlantic air, typically ending up at altitudes from 5 to 20,000 feet, forming what's called the Saharan Air Layer, SAL for short. The larger particles typically settle out, but the smaller ones linger and can cross the Atlantic, on average in 5 to 7 days, producing spectacular sunsets in southern Florida and the Caribbean, and even dulling the sky as far west as Texas. When the dust is in high concentrations, it's easy to see on visible satellite images, especially in full color. This was back in early August. This huge belch of Saharan dust was even visible on black and white imagery moving west across the Atlantic. When dust concentrations are lower, special infrared imagery that's sensitive to mid-level dry and dusty air can detect the SAL. Here, that dusty air appears in colors ranging from yellow to red, with red indicating relatively high concentrations. This was a 3-day period earlier this month, and the expansive Saharan air layer that shows up here is characteristic of much of the last month or so over the tropical Atlantic. And the Saharan air layer is like poison for a budding tropical cyclone, mainly because mid-level dry air makes it tough for thunderstorms to build vertically. And to make hurricanes, you need thunderstorms. Here's an example of how the SAL makes a difference. This graph shows relative humidity in the lowest 20,000 feet of the atmosphere above San Juan, Puerto Rico, back on August 1st. Now, this is a pretty moist atmosphere, relative humidity 70% or higher through most of the lower atmosphere. Now, here's 36 hours later. The Saharan air layer had arrived full force. Relative humidities above 5,000 feet dropped to be between 20 and 40%. This atmosphere has no chance of supporting tropical development. Plus, the Saharan air layer is relatively warm, and warm air aloft stabilizes the atmosphere, making the development of towering thunderstorms less likely. Here, the blue line tracks instability over the tropical development region of the Atlantic since May. The solid line is the long-term average. Notice that for almost all of this month, instability has been way below average, though just in the last day or two, it's starting to rebound, a factor that signals the tropics are likely to heat up in the next week or so. By the way, you might wonder how we know for sure that the dust and sand in the SAL comes from the Sahara. Turns out that Saharan dust contains distinctive minerals that allow its origin to be forensically traced to Africa. Research first published 40 years ago by Penn State meteorology professor Dr. Toby Carlson. Fred has the extended forecast next.